In this video chapter, I will discuss the critical spec measurements on the crankshaft to be performed before and after it is serviced by the machine shop. The purpose of this step in the rebuild process is to accurately determine if the crankshaft is still within acceptable factory spec wear limits. This is crucial information because it will determine the overall condition of the crankshaft, plus it will dictate what size main and connecting rod bearings to purchase for your engine rebuild. I will discuss this in more detail later in this video. For now, let's see what tools we will need. First, you need a good way of securing the crankshaft to your workbench in order to perform your measurements accurately. To accomplish this, you may use your flywheel, 3 or 4 flywheel bolts, plus a 6 to 8 inch C-clamp as you see here. Second, you will need a good quality micrometer with an accuracy of at least 5/10,000ths of an inch. It is a moderately expensive tool at a cost of $150 to $200, but it is necessary if you want to measure the crankshaft firsthand. You may be able to rent a micrometer as well at a high-end auto speed shop. I will mention that you may relinquish this measurement task to be done strictly by your machine shop, as long as you feel they are highly qualified and experienced with Porsche. If you choose to go this route, then request a detailed written record of the measurements for each of the main and rod journals before and after service is complete. In this way, you can double-check specs and play the role of quality control. Now, let's begin. Let me start by saying that this measurement procedure will apply for both before the crankshaft is sent to be serviced and after the crankshaft comes back from the machine shop. First, place the crankshaft on the workbench and verify the surface of the crankshaft is clean so it is not inadvertently scratched during this procedure. Now place the crankshaft on a vertical position on the workbench and have it stand and balance on its nose bearing. Next, take the flywheel and install it on the crankshaft flange as you see here. Use 4 of the flywheel bolts to secure it properly. Now simply rotate the crankshaft 180 degrees so that it is freestanding on the flywheel end. Next, use the C-clamp to secure the flywheel and crankshaft to the workbench as you see here. Now we are ready to begin our measurements. You want to obtain and record the following diameter measurements and compare them to the factory spec wear limits. As you can see, we have the flywheel flange at the end of the crankshaft. Then, as we move further along the crankshaft, you will find a total of 8 main journals and a total of 6 connecting rod journals. A full list of specs is on my website or on my mobile application. And finally, at the front of the crankshaft, we see the pulley shaft. Now I will show the basic technique to measure 2 of the journals. You may simply apply this knowledge to collect the rest of the key measurements on your crankshaft. First thing you want to do is to become familiar with your micrometer and how to properly take accurate measurements. This should be relatively easy by reading the instructions that came with your micrometer. Here I have a micrometer which I have properly set up to measure the number 7 main journal. Keep in mind that all the measurements will be taken in millimeters. Now simply place the anvil on one side of the journal and then simply rotate the ratchet thimble until the spindle touches the opposite side of the journal as you can see here. Once the spindle touches the journal, then you may use the ratchet stop to create a snug fit between the anvil and the spindle. Now you are ready to read the measurement of the LCD display. Here we have a measurement of the number 7 main journal of 59.988 millimeters. This is well within the factory spec wear limit for this crankshaft. This means it is a standard sized main journal. Next, I will measure the number 4 connecting rod journal. Here we see the final measurement to be 52.987 millimeters. Again, this is within factory spec wear limits, and therefore it is also a standard sized connecting rod journal. If all your main and connecting rod journals fall within specs, then your crankshaft is what is commonly referred to as a standard sized crankshaft. This means you will be able to purchase and use a standard set of bearings. Now, if your measurements reveal that your crankshaft is not within factory spec wear limits, then you have two options. One option is to regrind your crankshaft journals to a slightly smaller diameter and purchase a set of oversized bearings to match. Or the second option is to find and purchase a good used standard sized crankshaft to be used on your engine rebuild. Either one of these options is acceptable, but if given the choice based on similar costs to do either option, then I would lean towards the good quality used crankshaft option. Keep in mind the costs will vary over time for both the reconditioning option and the purchased of a used crankshaft option. That is to say that a used crankshaft may be readily available and moderately priced today, but not 6 months or a year or two from now. Therefore, my best advice is to discuss both options with your trusted machine shop to determine the best option for you given the unique market conditions and prices for used crankshafts at the time of your engine rebuild. Now that you have seen how to measure the crankshaft using the micrometer, you may simply apply the same procedure to measure the rest of the crankshaft critical specs. Make sure you write the dimensions down so you may have a spec measurement baseline for your crankshaft. These baseline measurements will come in handy when you speak with the machine shop technician about the services to be performed on your crankshaft. Also, once you receive the crankshaft from the machine shop, you will want to remeasure the crankshaft to verify it still meets factory spec wear limits. This is especially true depending on what services were performed on your crankshaft. If it was simply inspected and micropolished, then you should not see any difference on your measurements from your original baseline data. After you have documented all your baseline measurements, you may now pack and ship the crankshaft to the machine shop for inspection and service. On my next video chapter, I will discuss the proper cleaning procedure for the crankshaft after it has been serviced by the machine shop and returned back to you.